Hey guys, welcome back to the channel. Today I'll be showing you how I made this $3,000 desk lamp. I got the inspiration from Instagram user Kara Creates. When I saw their beautiful lamp design, I immediately thought to myself, this would look great as a PC case. And so it began. We start by cutting plywood for the hardware panel. Masking tape along your cut lines can really help reduce chip out. You can see the big difference here. With the right size piece ready, I then set up the patterns in X2 Creative Space. Followed by framing to make sure the cuts will fit on the board. The X2 laser has really sped up my workflow for cutting these panels. If you're passionate about DIY and woodworking, I recommend looking into getting one of these. The center spline connects to the rear panel using these tabs. Threaded inserts are added now before glue up. I also apply masking tape around the power supply holes before chamfering. This is especially important as chamfering near plywood edges tend to cause big chip outs. The two pieces can now be glued together. While the glue dries, all the mounting brackets were printed on my Prusa Mark III. More threaded inserts are melted into them using a soldering iron. On to some CNC work. I wanted to start small to get a warm up, so I decided to machine the bottom pendant first. A scrap walnut block is secured onto the spoil board using masking tape and super glue. I use these spacers to position the blank away from the datum, which allows bit clearance all around the part. Then, we slowly jog the machine to find the center of the block, set the Z height, and let it rip. I let the machine do its thing, but when I came back to check, I realized it had broke a bit. Because I had used a downcut bit, it was pushing all the walnut chips into the grooves as it cuts. This caused the bit to seize up and snap. I swapped over to an upcut bit and resumed the program, which worked much better. After the rough shape was achieved, I ran a parallel pass program to even out the larger steps in the slope faces. The parallel passes were done again using an even finer bit to get a better surface finish. I quickly test the buttonhole now as it would be easier to enlarge it while the part is still in place. As the button fits well, the piece is removed and flipped over. The button is widened and a channel is added for the wire, followed by a small chamfer to finish off the edges. The surfaces were then sanded lightly on 220 grit sandpaper to remove the marks. A coat of hard wax can then be applied. Some rustic rope wire will be used to connect the button. Heat shrink is added to stop the edges from fraying. A bit of hot glue is used to fix the button into the pendant. A barrel connector is wired up on the other end. On to the lamp base. I bought this large solid walnut block for about $100 Australian. To find the center of the block, I set up a right angle guide on the table, followed by marking the 45-degree bisector. Masking tape was used on the table to get a clearer mark. The block is then placed against the edges, and the mark can then be transferred. The opposing marks are joined with a straight line, and this was done in 3 other angles to get the center point. As the block wasn't truly round, I had to find the largest circle I could fit on it using a compass. I also transferred the marks onto the other side. The block did not have a fully flat face, so I had to shim it on the CNC to ensure it was stable. Masking tape was applied to the entire face and glued to the machine. First job is to flatten one surface using this surfacing bit. Because the block was so thick, I could not get my Z-probe under the bit. So I had to improvise and use a thin metal block instead. Make sure to change the parameter in the software to reflect this. I also marked the entire surface with pencil so I'll know that the whole surface has been machined when there are no pencil marks left. After a couple of passes, there is still this low spot that hasn't been flattened. So the bit is lowered by 0.2 mil and ran again. After taking away about 1 mil of material in total, we finally have a completely flat surface. The block is flipped and the same was done on the other side. Then I engraved the target circumference to check my bit positioning. The position was good, so we moved on to carving away the outer edge. I could only carve 20mm deep as that's the longest bit I have. The rest will be finished using a router. Next, we machine away the inner indent, followed by the grooves. Again, I check the fitment of all parts before removing the block from the machine, just in case. To even out the rest of the block, some masking tape is first added around the machined edge to reduce the amount of material removed in the first pass. A flush trim router bit is used to follow along the circumference. After the first pass, the tape is then removed for the final cut. Light sanding was done to remove the machine marks on the bottom. For the circumference, I sanded according to the grain direction to get a perfect blend. Have I ever mentioned I love walnut? It has such a lovely grain pattern. Shame it's so expensive here in Australia. More threaded inserts are installed into the base. The corners of the spline were rounded over to fit into the grooves. Okay, on to the outer sleeve. I wanted the sleeve to be easily removable from the base, so it will be a self-supporting structure consisting of top and bottom rings connected with 20 slats. The bottom ring is cut from 2 layers of 1.5mm walnut ply. Cutting the ring in 2 layers allows me to introduce grooves without using the CNC or router. The layers are glued and held in place with some weights. As you can see, my YouTube career is really taking off. I have so much cash to use as weight. He's lying. Please subscribe to support the channel. The top ring was oversized because it needed that extra material to keep its shape better due to all the slots cut in it. I can sand off the excess after it's been glued, as the bottom ring is now keeping everything in place. On to the top ring. This was also cut in 2 pieces of 3mm maple plywood and glued together. The slats were also cut using this same material. Inner edges of the slats were tapered to make more internal space for dust filtration later. All the pieces were given 2 coats of spray varnish, including the edges, which seals the carbon in and prevent black fingers when handling. While those were drying, a wire mesh was formed into a fitting cylinder shape. Some fabric mesh is then cut to size. As the fabric is soft, I sewed it onto the metal mesh to get a rigid dust sleeve. Before glue up, a piece of baking paper is placed on the base to prevent accidental glue from ruining it. Bottom ring is set in place, followed by the dust sleeve. Then the first 3 slats are carefully positioned to hold up the top ring. The rest of the slats are then slowly added into formation. At this stage, the structure is still very fragile. Once in position, superglue gel is used to secure everything together. A bead on the bottom ring and a couple drops in the top notch, then held for 30 seconds. I then mark each glued slat with tape so I can keep track of them. Rinse and repeat for the other 19. On the back end, I added these mini slats to complete the circular loop while still providing access to the component IOs later. Foam strips are added to critical edges of the rear panel. These will create a seal with the dust sleeve so air has to pass through it, getting filtered in the process. The base is then given a coat of hard wax. Initially, I designed the LED groove to be flush, but ended up printing a 2mm space to elevate the LED strip. This creates an internal lip for the sleeve to rest against. These slits are cut along the top of the sleeve so they can bend inwards to seal against the top ring. More foam is added around the fan grille. LED strip is wired and pulled through the channel. With that, we're ready for assembly. If you liked the video so far, give it a like and consider subscribing to my channel. Projects like these take a long time to design and execute, and your support allows me to continue to make more content for you. Now, let's get back to the assembly. Center spline is slotted in. Three locking tabs hold the spline in place. A quick operation on my previous build as I will be reusing some of the parts. ID cooling IS55 is installed. PCIe riser clicks in. 6mm standoffs for the motherboard. LED strip goes in, followed by the power supply. Printed brackets attached on the GPU. 10mm standoffs for the PCIe riser. GPU is then mounted onto the spline. DisplayPort extension used to allow connection from the rear panel. Female barrel jack added for the power button connection. When I tried to wire it all up, I realized the SFXL PSU was too large, so I swapped it for an SFX size instead. Cables are rather messy for this build, but it will all be hidden away later. Fan bracket goes on. Arctic P14 ARGB fan will provide the ventilation for this build. Dust sleeve is wrapped around the components. Then the outer sleeve can slide over it. And here we have it, my RTX powered desk lamp. On to some testing. On full synthetic load, the CPU reaches 84C and GPU sits at 86. This is with the fans cranked to almost max at an honestly unbearable noise level. Thankfully, on a more realistic gaming load, the CPU only gets to 70C with the GPU sitting at 60. The fans only give off a light hum in this situation. I wouldn't recommend loading this case with high-end components. A 60 class GPU with an i5 or Ryzen 5 CPU would be a great pairing. What do you think of this build? Would it fit well in your workspace? Let me know in the comments below. As always, thank you all for watching to the end, and I'll see you in the next one.